Hello again, it's Jason from STEMonline.com, where we are a math and physics online tutoring company, where we specialize in helping students from grades 11 all the way up to and including second year university courses. Okay, so in today's video, we're going to look at helping AP and IB and even university students with partial fractions and integration by parts. This problem will combine both concepts into one. Okay, so if you're having trouble with that particular area, this video is for you then. Okay, so we're going to solve the following problem. We're going to integrate e to the x all over x plus 1 with respect to x. Okay, yes, this is a bit of a tricky problem. Yeah, okay, but I will try to simplify it. All right. So the first thing we should probably look at, okay, is using a substitution type method. Okay, so what I'm going to do is I'm going to let u equal to, let u equal to x plus 1. Okay, let's let u equal to x plus 1. All right. There's a reason why I let u equal to x plus 1 and not e to the x. And the reason for that is because with u equaling to x plus 1, then I can solve for x easily. Okay, so then I'll have u minus 1 is equal to x. All right. So then we have this. Actually, I'll put it over here. Might be better. I'll put x over here. So x, this implies that if we solve for x is equal to u minus 1. Okay. Now, why did I do that? Well, I want to take the derivative with respect to x and with respect to u. Okay, so therefore, if I find the differential of this, dx is equal to du now. Okay, then from this I can substitute this information back into the integral. Okay, so my integral of e to the x all over x plus 1 with respect to x is equal to integral of, well, let's see what, rewrite everything in terms of u, because that's the point of this. We're using some type of a u substitution here. So we're using u substitution before using the other methods like partial fraction and integration by parts. Okay, so replace all x's with a u. Okay, so e to the u minus 1 power. Okay, so we have it written to e to the power of u minus 1 all over x plus 1, which is u, with respect to u. All right, so now we have this. Okay, but yes, this does look a bit tricky, because we don't have, right now, the integral that we have as a function of u is not written in any of the formulas that we know for integration. Okay, there's no formula for integration that is of this form, so we have to keep modifying it. In other words, you have to keep, the way to do these is you have to keep modifying the equation until you come to a formula that it resembles. Okay, otherwise you're going to be in trouble. You're going to go in circles. So if we need to modify this, we need to rewrite this in an expression that is equivalent. So this can be rewritten as the following. Okay, notice how, yep, so I want you to notice how e to the power of u minus 1 is equivalent to e to the u times e to the negative 1, okay, all over u. This is due to the fact of exponent laws, right? Okay, anytime when you're, adding or subtracting exponents, you're taking one base times the other base and then adding their exponents when you're multiplying similar bases, right? Okay, so we have this. Then you're going to notice something else. E to the negative 1 is a constant. There's no dependency on as a function of u, so I can move, this is just a pure constant. Move this to the front, this becomes e to the negative 1. and then just integrate e to the u over u du. See, now it becomes somewhat simpler. Okay. All right, so that's the next thing. All right. The next thing you want to notice here is that this is an exponential integral. Okay. Yes, an exponential integral. What is that? So just make sure you remember. So we actually have a formula that you should know from your either your university calculus class or from AP or IB calculus. Is that the formula is that if you have the integral of e to the u over u du, okay, this is equivalent to the following: e I of u plus c. This is called an exponential integral, okay? So since we finally decomposed our complicated problem into a formula that we know, we can now substitute the information in, okay? So substitute this formula, okay? Substitute the formula above, okay? So we're going to substitute this. So this now becomes, this is now going to become e to the negative 1, right? E to the negative 1 of the integral of e to the u, e to the u, e to the u, all over du, okay, all over du, sorry, e to the u over u, yeah, e to the u over u du is now equivalent to e to the negative 1, okay, times, all in brackets, the exponential integral, right, capital EI of u plus c, okay. All right, so now we have this, right? So what do we do from here? Okay, well, there isn't anything else that we can do except for following this out, right? So this is now equivalent, right? So this e to the negative 1, sorry about that, e to the negative 1, e to the negative 1, integral of this, e to the u all over u du, right, is equal to e to the negative 1 capital E I of u plus c. And one last thing is substitute u for x plus 1. Why do we need to do that? Anytime when you use a substitution method by substitution, or use substitution here, once you've integrated and found the solution to the problem, you have to make sure that it's written in terms as a function of x, variable x, so we have to eliminate the u. So since u was equal to x plus 1, substitute that in. So our final result here for the integral of e to the x with respect to x all over x plus 1 is equivalent to e to the negative 1 exponential integral of x plus 1, because we placed the u, and then plus c, and that's it. Okay. All right. I hope this video has helped you understand partial fractions and integration by parts. If you have any other questions on this topic or struggling with calculus in general, you can contact us at www.stem1online.com for more tutoring. Like and subscribe to the video, and I will see you next time.